Welcome to the study of kinematics. If you are new to this field, you are in an excellent place to begin. In this tutorial, we will examine three fundamental equations, two that describe average speed, and one that focuses on acceleration. Once you have a solid understanding of these concepts, you will find that kinematics becomes considerably more manageable. Let us begin. The goal of kinematics is to describe movement. Let's illustrate this by examining the movement of a ball from point A to point B. To understand motion, we need to establish the concept of position. Let's label point A as the starting point and point B as the end point. Suppose the distance from point A to point B is 10 meters. To describe motion, we need to measure it with respect to a quantity that indicates movement or change. That quantity is time. If the ball travels from point A to point B in 10 seconds, it means the ball covers 10 meters in 10 seconds. Simplifying this, the speed is 1 meter per second. This speed is referred to as average speed. This is what we mean by our first equation. The average speed is obtained by dividing the total distance with the total time. Average speed provides a general description of the overall motion. It is possible for the ball to stop midway and then roll faster toward the end to still meet the 10-second duration. Another way to determine the average speed is by calculating it as an average, which is quite straightforward. You can find the average by taking the mean of two or more speed observations. Before doing this, let's understand the concept of instantaneous speed. Instantaneous speed is the actual speed of an object at a specific moment, usually measured using instruments. Let's use our example of a ball rolling from point A to point B to illustrate this. Imagine we place instruments at labeled points 1 and 2 to measure the ball's speed as it rolls. The ball might start at a high speed, say 1.5 meters per second, and then slow down to 0.5 meters per second. These measurements, referred to as v sub 1 and v sub 2, are examples of instantaneous speeds. To find the average speed based on these observations, you add the two speeds together and divide by 2. In this case, adding 1.5 meters per second and 0.5 meters per second gives you 2 meters per second. Dividing by 2 results in an average speed of 1 meter per second. This is what we mean by our second equation. The average speed is obtained by getting the mean of several observations. Since it is a mean, do not forget to write the symbol correctly by placing a bar over the symbol for speed. Finally, our third equation describes the change in speed over time, which is known as acceleration. To find acceleration, calculate the difference between two instantaneous speeds and divide it by the time over which this change occurs. Let's demonstrate this using our example of a ball moving from point A to point B. Suppose the ball starts at 2 meters per second at point A and gradually slows down to a stop in 10 seconds at point B. To calculate acceleration, we divide the change in speed by the change in time. The change in speed is 0 minus 2 meters per second, which equals minus 2 meters per second. Dividing this by 10 seconds gives us minus 0.2 meters per second squared. This means the ball's speed decreases by 0.2 meters per second every second, taking 10 seconds to reduce from 2 meters per second to 0. Now let's test our understanding with this problem. An object starts at 12 meters per second and gradually slows down to a stop in 3 seconds. We need to find the distance the object covers and its average acceleration. The initial speed is 12 meters per second, which we'll denote as v sub I. The final speed is 0 meters per second, denoted as v sub f. Both of these speeds are instantaneous. Can you guess the average speed of the object? If you guessed 6 meters per second, you're correct. Next, let's complete our list of known values by including the time, which is 3 seconds. We also need to list the required quantities, distance and acceleration. When the problem is organized this way, the solution often becomes more apparent. Understanding these symbols in kinematics, along with some basic math, can make problem solving much easier. From the given information, you can quickly calculate the distance since you know the average speed and time. In this case, the distance covered is 18 meters. Similarly, you can find the acceleration using the initial and final speeds and the time. The acceleration is negative 4 meters per second squared. That concludes part 1 of this course. Next, we'll derive the other two kinematics equations, which are combinations of the three equations we discussed here. Would you like to see these kinematics equations explained using a graph, or maybe go through more sample problems. Stay tuned.